Gabriel's horn, also known as the painter's paradox, is a great example to study calculus with. The topic of infinity is really a great example. So first of all, you have the function 1 over x, which looks roughly like this back here. There we have an asymptotic behavior towards the x-axis. And if we now choose the point at 1 accordingly, reflect the function over the x-axis, then it looks roughly like this going downwards. Well, roughly like this. And if I now draw it here at about 1 and then keep going, and that would now be a rotation around the x-axis, and this rotation then results in the following. Back here it would be exactly, there it goes towards infinity, but it never reaches it. That would be Gabriel's horn, so from 1 to infinity going back. And now let's take a look at two things. We'll look at the volume of this body, and we'll look at the surface area that is created here. And the surface area would be calculated with 2 pi, integral 1, from a to b of f of x times the square root of 1 plus f of x squared dx. And the volume would be calculated with pi times the integral from a to b of f of x squared dx. Now the volume, if you look at it, seems to be a bit easier. Let's start with that. We have accordingly pi times the integral from, we start at 1, from 1 to infinity, 1 over x inserted, to the power of 2 is 1 over x squared dx, 1 over x squared. Now there are a lot of little details. That's why it's rewritten. X to the power of minus 2. And x to the power of minus 2 is then relatively simple in terms of the antiderivative. That would then be pi times. The antiderivative would be minus x to the power of minus 1. You can check the whole thing from 1 to infinity. Minus 1. Now if we were to differentiate that again, minus 1 times minus 1 is plus 1. If you subtract 1 from the exponent, it would be x to the power of minus now, upper value inserted, minus lower value inserted would be pi times. And then minus infinity to the power of minus 1, minus 1 inserted, minus 1 to the power of minus 1. Yes, just like that. And if we rewrite this now, we have 1 over infinity here. That, of course, becomes 0. Minus and minus gives plus. 1 over 1, 1 is 1, so the result is 1, which means that's actually the outcome here. Pi, which means the volume is finite. And specifically, Gabriel's horn can hold pi units of paint. That means if you were to take this horn, turn it like this, and take a paint bucket man who has pi units of paint, we could fill the horn completely. Now let's look at the surface area. Now it gets interesting. We have 2 pi times f of x times the square root of 1 plus f prime of x squared. So we need the derivative of 1 over x. Yes, if this is f of x, then f prime of x equals. We can rewrite this as x to the power of minus 1. Then if we differentiate x to the power of minus 1, it's minus x to the power of, subtract 1 from the exponent, minus x to the power of minus 2. Or written differently, minus 1 over x squared. Now if we plug these things in, we have 2 pi times the integral again from 1 to infinity. F of x is 1 over x times, and then the square root of 1 plus, and then minus 1 over x squared, the whole thing squared d. And that looks very complicated now. And before we tackle this one here and look for an antiderivative, we'll use a couple of mathematical methods, namely to estimate a little bit. And we'll focus first only on this expression here, namely the square root of 1 plus or minus 1 over x squared to the power of 2. No matter what values we use for x now, yes, if we plug in a value for x below, it will definitely be positive. Then there's -1. A negative value divided by a positive value raised to the power of 2 becomes positive again, so the whole thing results in 1. The square root of that will definitely be greater than 1. That means this expression is definitely greater than 1. Then we can now say, let's first take the much simpler integral from 1 to infinity of 1 over x. If we use that now, since it's always greater than 1 anyway. Yes, dx, let's calculate this integral, because we know that it will definitely be greater. You'll see in a moment why this fits here as well. Here we have 1 over x times 1 is 1 over x, and now of course we need to know the antiderivative of 1 over x. That means we get 2 pi times ln of the absolute value of x from 1 to infinity upper value plugged in minus lower value plugged in. There we have 2 pi times ln of the absolute value of infinity minus ln of 1. Yeah, ln of 1 is 0, so we're left with ln of infinity, and that's infinity. 2 pi times infinity. That means we get infinity here, and since this is definitely greater, we're also at infinity there. That means the volume is exactly pi, so we can fill in exactly pi units of paint, but the surface area is infinite. That means if we tried to paint the outside with paint, we would never finish. And that's the paradox called Gabriel's horn. Feel free to write in the comments if you want more videos like this. I find it very interesting. There are still plenty of opportunities to make other videos on different topics. As I said, that's the paradox surrounding Gabriel's horn.